Okay, this is for year 12, digital technology, and it's on how to convert something like that, which is a remote control, which I haven't finished yet, or something like this, which is a remote control, which does work. So this is a nano, which is wired in with 4 buttons, and I've got 2 infrared transmitters there. This will drive an infrared robot like that. So this has got an infrared receiver on it, which will work. So what I am going to do next is this one's an infrared. That's the infrared receiver there. I am actually going to change this one to a radio one, and the reason I'm doing that is because I want to know if a radio one, you might be able to see better now, I want to know if a radio transmitter actually works better than the infrared one. Okay, and that would be part of my testing and development, and it's part of my iteration plan as well, to test the different mechanisms of transmitting data from my remote control. So I haven't made my final outcome yet, because my final outcome is going to be something which is actually in a box, or I'm actually looking at this, which is which I took off a previous one. So I've got fixed buttons which are labelled on here, and I've also got some other buttons down here which I might use for something else, like flashing lights if I score a goal during my football match. And I've got an LCD screen which I might put something on, but that would be much later down the road. That's part of my iteration plan, would be to get these buttons here working properly. Then I might put some information on here for the user feedback, and then I might get this thing. The other thing which I thought is, have I had a servo which controlled a grabber at the front for the ball, then these buttons here could be used for like grab, release, and score, which would flash lights or play sound or something. Anyway, if we look back at this, we can try and work out what's going on. It might be easier to see on this one. Now, if I take that's the radio transmitter, I'll take that out so you can see what I've got. I've got my 4 switches. On the left-hand side of this, I've got it connected to the ground via a pull-down resistor, which is like a 30 kilo ohm. On the right-hand side, I have got it connected to the positive. Now, each switch is like that, but if you look at this one here, this has got a wire in with the resistor. That is the wire which goes to the Arduino. So this breadboard at the moment isn't completed. This is what I'm going to use to test the radio. So my left-hand side has a pull-down resistor going to the ground. That's to hold the voltage of the switch pin down at 0 volts unless we press it. If we press it, it will connect the 5 volts across there, and because that's such a large resistor, it will still basically be 5 volts there. Arduino can recognize that as a high digital signal, so you do your you do your digital read, test to see if it's high in your if statement, then it will recognize that. So how would we go about putting that onto a solder board? I'll just pause a second, I'm going to find a solder. Okay, so the solder boards that most of you got are these things here, and we need to work out how to put it on. This is something which one of the year 12s built, not last year, but the year before actually. And you can see that they've soldered it all together on the back. The reason they put it on the back is to keep the front clear. This wasn't for a remote control, but you could actually change it to a remote control. So on the back here, this is the wire which will go to the Arduino to read the pin. That has connected to it a resistor, and if you look carefully and we bend some of these out, you'll actually see that all those resistors are actually wired to one place, which then goes to this wire here. This wire here should be black, because the convention says that it's that ground or negative or earth is black by convention. This is a common, and all the grounds are all wired together. That's why you can stick them all together. somewhere in here, if you look carefully, you'll see, oh, there's one there. So you'll see that this little wire here connects through onto this orange wire here. Now that would be wired to the 5 volt. There is another little wire there connecting that side to the 5 volts. And if you looked carefully in here, you would find the other wires connecting to the other switches. So I thought, how would we actually do this? So if you laid it out as 4 switches like that, you could put a ground in the middle, like that. And then you could connect, you don't have to do it this way, you could connect your resistors through like this to the nearest pin. Like that. You need to pay attention to what you're doing because it's your design. You're going to need to draw it out and work it out yourself to some extent because that's part of the task. This pin here, this pin here, this pin here, and this pin here would be the button pins. So they would go to the Arduino, and you might be using like A0, A1, A2, A3 for that. Those are the pins on the Arduino. The other thing which you're going to need is you're going to need it connected to the 5 volt. So what you could do is you could just take one point like there, and you could then take some jumper wires and you could just connect that through. It's up to you how you do this. In fact, you wouldn't need that. See, there are other ways of doing it. If you look at this one here, I've got a cross with that one there, but it's actually that one could be soldered onto there because that's all 5 volts. So this would then come off in the red wire, which would be go to the 5 volts on the Arduino. And it really is as simple as that. Somewhere on there you need a transmitter, and so you could put it on the transmitter up here, and you can wire that in some form of appropriate fashion. Here is a child. Alright, let me know how you go on. If you've got any problems, you can now question me about this and we can discuss it on email. Thanks, Year 12. Enjoy that.